Hello, welcome to another video of Code Snippet. So in this video, we are going to look into the last pillar of OOPS, that is abstraction. So until now, we have already seen inheritance, encapsulation and polymorphism. In this video, we are going to cover the last one, that is abstraction, which is very important pillar of OOPS. So let's first understand what exactly is abstraction, and after that we will see how we can implement that inside Java. So let's get started without wasting any time. This is going to be a fun video, so sit back, relax and enjoy the show. Right, so let's quickly jump into the agenda of this particular video. So abstraction, right? So first we will understand what exactly is abstraction. After that we will see why we need abstraction and why abstraction is very important inside Java. After that we will see how we can achieve abstraction inside Java. So there are basically two methods. One is by using abstract classes and another is by using interfaces. Well, interfaces is again a very interesting and important part that we will see in the upcoming video. After that, we will see the implementation of the abstract classes inside Java. So that is basically the overall agenda of this particular video. Right, so let's get started and let's see what exactly is the definition of your abstraction. Abstraction is a process of hiding implementation details and showing only essential functionalities to user. Now this is a theoretical statement. Let's try to understand it with an example, right? So this is the example that we have already seen when we have seen inheritance, right? So we have one class and multiple classes will extend that particular class. Let's say we have one car class and we have multiple subclasses. User usually interact with this particular class, right? So car is basically an entity for me, right? So car is something which I can drive, right? So what I know how to drive car, right? But what exactly is happening behind the scene, how the engine is being framed and how it is generating power, how the car suspension is working, all these things are not in my hands, right? I don't need to understand that in order to drive a car. All these things are abstract for me, right? That means those things are there doing their job, but I don't need to understand them. So that thing is basically abstract for me. And me being a user, I will interact with only car, right? So let's say here I'm a user of a car. So I'm going to use this particular car, right? So I will interact with your car class, right? Your car class I will interact with. Now each car, let's say it's a Tesla car, BMW car or Audi car, it will have its own engine, right? It will be a different engine. Each one will have its own engine. They will have different kind of engine and each engine generating different kind of power, right? But I don't need to know that, right? As a user, I know how to start a car by pressing a button or using my key, but I don't know how the engine is actually being started, right? So all these engine related things are abstract for me, right? I just know how to start a car. So I will just interact with this start car function. I'm not aware how these cars are actually starting the engine, right? So there might be a function inside a Tesla car which have an implementation of how to start this engine, right? But as a user, I don't need to know the implementation. I'm just happy by using start class function, right? That is basically abstraction. This start car function is abstract for me, but the actual implementation is hidden inside your subclass, right? So I don't need to remember that, right? I don't need to understand that, right? So that is basically abstraction for user. All these things related to engine, starting a car are abstract, right? So what we do, we define this car class as abstract class and the child classes which are having the actual implementation will extend this particular abstract class. And this particular car class will provide abstraction for us, right? Now we will see how actually we can achieve that, right? Now let's go back over here. So that is basically the definition. Now that we have seen the example, let's again try to read this definition. So abstraction is a process of hiding implementation details and showing only essential functionalities to user. Now is it making sense? Now start car is an essential detail that your user should be aware of, right? And these implementation details that are present inside your child classes are hidden from your user. User only can see the start car function. What exactly is happening behind the scene? This guy user don't have to do anything with that, right? He just know how to start a car and how to drive it. That is fine. So all these things, all this implementation part is abstract for this user by using this particular abstract class car, right? Now let's see why abstraction is important, right? First of all, it reduces the complexity. The user doesn't need to know how the feature is being implemented. Your user doesn't need to know how the car is actually being started. What exactly is happening after you press a button. As a user, I just know that I need to press this button to start a car. But what exactly is happening behind the scene, I don't care, right? I just want my car to be started, right? So that's me. This reduces the complexity. I don't want to understand what they are doing behind the scene. They are taking a lot of my money to give me a car, so I don't care what is happening there, right? I just want my car to start normally when I press that button. After that, it increases the maintainability. Changes inside implementation doesn't really affect the user, right? Tomorrow, if they decided to change the implementation of how the car is going to start, I'm still going to press that button only. But behind the scene, they will change something, right? So that's how it increases the maintainability, and it will improve security as well, right? Only necessary details are exposed to user, reducing the risk of misuse, right? So that will increase the security as well, right? So that is the reason why abstraction is important in this case. So we have seen what is abstraction, and we have seen why it is important, right? Now we will see how we can achieve abstraction inside Java. Now, when it comes to abstraction, you can achieve it by using two ways. First one is by using abstract classes, and second one is by using interfaces inside Java, right? Now, when we say abstract classes, it's kind of a partial abstraction, and when we say interfaces, it is a full abstraction, right? So it might not be making that much amount of sense at the moment, but when we see it, the things will be more clear, right? So in this video, we will see what exactly are abstract classes, and in the next video, we will see what exactly is interfaces, and we will also see the difference between abstract classes and interfaces. This is a very popular interview question, right? So we will cover that as well. So let's actually jump into the code and let's see how we can implement it. So if you see over here, this is basically the example of inheritance, right? So if you see over here, we have a car class. Class Tesla is extending a car. Class BMW is again extending a car. We have a main method inside abstraction example class, where we are creating an object of car Tesla, and we are starting a car or playing a music inside car, right? Now if you see over here, car class have its own implementation of start car. Then if you go over here, Tesla car will have its own implementation, right? After that, if you go over here, then BMW car will have its own implementation. Now if I run this code, what will happen? Let's quickly analyze that. So if you see, Tesla starts with push button, right? So if you see over here, the start car is basically starting with push button for Tesla car, but BMW guy will start with the key, right? Now if you see over here, Tesla car's start car function is being called. Now here we have this implementation of start car which is not actually being called, right? And do you think it is needed at all, right? It's not needed, right? If you see over here, we are not providing the actual implementation of how this car is being started, right? We are just saying starting a car, which is not necessary. If it is a specific car like Tesla, then we know how the car is going to start with the push button, right? And we have some mechanism over here to start the car. But car is just an imaginary entity. We don't know which car it is and how it is going to start, right? Car is basically a four-wheeler drive in my mind, right? But exactly which car it is, that this subclass is going to tell us, right? So this starting a car is not making sense to me, and the implementation of this method over here is not making a sense. So what we can do, this imaginary entity which is a car, we can mark it as abstract. And how we can mark it as abstract? By using abstract keyword, right? And now in this case, we can just remove this implementation and just give a semicolon. But once I give this semicolon over here, this guy will still cry because it's saying, okay, dude, you are missing a method body over here. Either you need to add a body to this particular method or mark this particular method as abstract, declare abstract, right? So we need to make this method as abstract as well. So now this is the abstract method for user, which implementation will be provided by its child classes, right? So here will be the implementation, or rather here will be the implementation inside this particular class, right? Now we won't get any error, but we can still have normal method with the implementation. For example, this play music class inside this particular car class, right? So we have abstract plus non-abstract method inside your abstract class, right? That's why it is not a pure abstraction, rather it's a partial abstraction. If you go back over here, this abstract classes are basically your partial abstraction. They provide partial abstraction instead of providing a full abstraction, right? Full abstraction interfaces will provide, that we will see in the upcoming video, right? Abstract classes can have abstract and non-abstract method. Now your child classes will provide the implementation of star class. Now as a user, what I'm going to do, I'm going to create object of car class. And what I will do, I will just say my car.start car. Now how the car is starting, that implementation is hidden inside your child class, right? I just know that, okay, I need to call this particular abstract method. So that is how you can achieve abstraction inside Java, right? now only essential functions are exposed to user over here, rather giving the actual implementation. And when we work inside Java, Java already have a lot of abstraction provided to us. And when we work inside Java, Java provides a lot of abstract classes or interfaces to us. For example, let's say we have a list, right? Now what is a list? List is basically a collection of object, right? Now in Java, Java has created a collection framework, right? Collection framework for us. Now if in case we want to make use of list inside Java, what you do, you just create a list of string. Let's say I want to create a list of string. What I do, I just create a list of string, right? So this array list and everything we will see later. Don't worry about that right now. Just see that how Java is helping you to create a list, right? Now I am the user of the list at this point of time. Now if I go inside this list is an interface, right? Which is basically abstract for me. And this list provide a lot of functions. So if you see, int size is empty, I can check if the list is empty, what is the size of the list, is the list containing this particular object, all these things. Do you see a implementation over here? As a user, what I need to know that, okay, what is the size of the list? If I call this particular method where I'm using it, let's say for example here list dot size, then this guy will return me the size, right? But do I know the implementation? When I look at here, I don't know the implementation. I don't know how this guy is calculating the size. I need not know, right? It is doing its job. I will get this size over here. If I catch it inside a variable, I will get a size over here inside this size variable. I don't need to know what is happening behind the scene inside this size function, right? So this is basically abstract for me, right? I just know I want to calculate the size and I know that, okay, this particular method will give me the size. That's it. But how this interface is calculating that size for us, it is abstract for me, right? So interface is again one of the type of abstraction, as we have seen this abstract classes, right? So abstract classes will also give me this abstract method. Interfaces will also give me abstract method. If you see over here, this method here, we don't need abstract keyword because everything inside interface is abstract by default. We will see that in detail in the next video, right? So the implementation of this start car is basically here inside the Tesla car, right? Now where is the implementation of this list? So if you go inside this list and if you see this particular arrow over here, then you can see as we are making use of array list, the implementation will be inside the array list, right? So here it is returning the size. So here is basically the implementation. For example, size, it will just return it. Is empty, it will calculate if the size is equal to 0 and it will return the boolean to us, right? So if you go back over here, we are creating a new array list, right? So here array list is similar to this Tesla car, which is providing the implementation of this list. As Tesla car is providing the implementation of this car class, your array list is providing implementation of this list class, and the actual implementation will be inside this array list class. But what we know, we just know that there is a size function which will return me a size, or there is a start car method which will start a car for me. I don't need to worry about how the car is being started, or I don't need to worry about how the size of the list is being calculated. So this is basically the real example that we usually make use of inside Java. And this is your real life example, which you will make use of inside real life applications when you develop one, right? So that's how you can make use of abstract classes, and that's how you can achieve abstraction inside Java, right? So that is how you can achieve abstraction. That is basically partial abstraction. We have seen what are abstract classes. We have also seen the implementation part as well. So in this video, we have understood what is abstract classes. We have understood how we can implement that. And we have seen what is the use of that. Now in the next video, we are going to deep dive inside the interfaces, right? So this is again an interesting part, and this will help us to achieve the full abstraction inside Java, right? And after that, we will understand the differences between abstract class and your interface, right? So it's a famous interview question and you need to answer it in right way. And you need to answer that considering a Java 8 features as well, right? So that is something which we are going to look into next video. So it is going to be an interesting video. So if you don't want to miss that, subscribe to Code Snippet right now. If you like the video, hit the like button. Don't forget to subscribe to Code Snippet. Share this video with your friends so that they also have understanding of what exactly is abstraction inside Java and what exactly are abstract classes. That's it for this video. See you in the next video.